So, good afternoon, everyone. My name is Valentina Ferretti. I am a fellow in decision science working in the Department of Management of the London School of Economics. And the work that I'm going to present you today deals with the regeneration of disused railways using an integrated analytical approach. This work has been developed in collaboration with Alessandro De Giovanni and Maurizio Arnone from the Institute on Territorial System for Innovation in Turin, in Italy. And before getting into the details of the presentation, I would like to thank the committee for this opportunity and for the helpful feedback provided during the interviewing process in November. So how is this talk going to be organized? We're going to start from the contextualization of the intervention and explaining also why this is an unusual context of application for analytics. We will then zoom into the intervention deployment to see how we actually used analytics in the context under analysis. And finally, we are going to discuss the impacts of the intervention and some current developments as well. So let's start by talking about the problem, the decision-making problem under analysis, and why this represents a problem. We are aware that the current economic crisis has yielded to the necessity of rail services reorganization in many areas, both urban areas and rural areas, resulting sometimes in their suppression and replacement with bus services. So together with railways abandonment, there are also station buildings that fall into disuse, and together they represent a huge heritage asset of relevance at an international level. Just to give you an idea why this is a problem that has an international relevance, we can see that there are more than 240,000 kilometers of disused railways in the US, more than 7,000 kilometers of disused railways in Spain, 7,500 kilometers of disused railways in Italy, and more than 2,000 in Belgium, which is a rather small number, but we have to know that Belgium, the Netherlands, and Scandinavian countries are really at the forefront for regeneration processes of disused buildings and infrastructures. So there might be different reasons behind this phenomenon across the different countries. Could be economic reasons, could be technological reasons, or environmental reasons, so changes in the land conformation. However, the abandonment of railways and infrastructure represents a problem from multiple points of view, because it can lead to natural environmental degradation. It can lead also to structural failings and thus safety problems. It may lead to illegal waste disposal, and it can have a negative aesthetical impact on the landscape. Positive news is that it not only represents a problem, but also an opportunity, because we can find new uses for this abandoned infrastructure, and these new uses provide opportunity, for example, for low-carbon travel experiences. They also help to arrest decay processes, and they help to re-establish continuity in the environmental system. So there is a lot of attention going on towards the regeneration of abandoned infrastructures, as well as the regeneration of abandoned buildings across many countries. And there are several reasons for that. First of all, this kind of infrastructure usually represent our economically attractive sites, as they are very close to central districts. They are usually very well connected, and the reclamation costs as well are usually smaller compared to reclamation costs for former abandoned industrial buildings. So what can we do with abandoned railway lines? There are many things that actually we can do. There are many best practices available worldwide. Some of them are very creative. And so, for instance, you might be familiar with that, but a very successful example of regeneration, urban regeneration of linear infrastructure is here in the US, in New York, the High Line in the city center of Manhattan. This was an abandoned railway line that stretches for 6 to 7 kilometers in the very city centers, 10 meters above the ground, and it has been recovered as a greenway for pedestrians and runners, and it became a very successful example of urban regeneration, which is now regarded as a best practice worldwide. Similarly to the High Line in New York, we have the Promenade Plantée in Paris. Again, some of you may be familiar with that. Again, 6 kilometers of an abandoned railway line in the very city center of Paris, which has been recovered as greenway for pedestrians, again 10 meters above the ground. But there are other things that we can do. So, for instance, if you think about abandoned station buildings, you might be surprised to know, but Musée d'Orsay in Paris, which is one of the most famous museums worldwide nowadays, was actually an abandoned station building. And also in the south of Italy, we are starting recovering abandoned station buildings, and some of them actually became luxurious hotels and residences for tourists. So there are many things that we can do. The context of our application, we are in Italy, where there are more than 7,500 kilometers of abandoned railway lines, 90% of which has been evaluated as suitable to be recovered for touristic purposes and ecological valorization. But actually, understanding what would be the most suitable option to regenerate an abandoned infrastructure is not an easy task. It is indeed a complex decision-making problem, as there are multiple and often conflicting objectives that we have to take into account, and multiple stakeholders that we also need to involve. So, who are the clients of our intervention? We were working for the Piedmont region, the transportation sector in the northwest of Italy, and we were working with the Institute for Territorial System and Innovation, located in Turin, that is the capital of the Piedmont region. And but let's see why the context of our application represents a new area for the application of analytics. We are dealing with public policy making and regeneration processes. And this context of application needs targeted analytics, which have been recently discussed and proposed in a paper authored by Tsukias et al. They have been named policy analytics. What are policy analytics? They are an emerging field of both research and application of analytical methods that are able to support public policy decision-making, problem-solving, and planning processes. And basically, we think that the rapid progress in business analytics, which seems to suggest that the huge potential for the use of analytics in many different fields, is also applicable to the context of public policy making. But what makes a public policy process different from any other process? There are several characteristics that are strongly interconnected here. The first one is the use of public resources, both tangible and intangible, and that's why a policy can be defined as an irreversible allocation of public resources, thus giving rise to intergenerational, social justice, and environmental issues. The second characteristic is that there are multiple stakeholders involved in the decision-making process, so there is a bigger need for participation throughout the different steps of the policy-making process. We have long time horizons for the consequences of a policy cycle to become visible. We have needs for both legitimation and accountability of the process and its results, and there is a need for a constructive learning approach in this context. So here you can see that policy analytics can actually provide a crucial support in the different stages of the policy cycle, starting from issue identification to the definition of policy objectives, policy design, policy testing, finalization, implementation, monitoring, and so forth. And actually, policy analytics can generate policy innovation because they can foster sustainability in the policies, they can enhance timeliness in the materialization of the policy impacts, they can also increase participation, and they can help to actually identify and include community needs into the decision-making process. So let's now move to the intervention deployment. That is the second part of the presentation and the core of the presentation itself. The objective of our intervention is to investigate which role integrated decision analytics can play to support heterogeneous impacts aggregation in transportation planning, by discussing in particular the operability, the applicability, and the transparency of the developed approach. So here you can see a schematic representation of the decision-making process that we developed in this intervention. As you can see, we started from the definition and the structuring of the decision problem. We then used several problem structuring tools, stakeholder analysis, value-focused thinking, and best practices analysis to identify both the objectives under consideration for the specific decision-making context and the possible alternatives for the solution of the problem. Then we used focus groups and experts panels in order to elicit preferences from the client and the stakeholders involved in the process. And we finally obtained a recommendation for the decision maker. What I would like to highlight is that in this picture you can see the different analytical components that we integrated in the intervention. So, for instance, we integrated visualization tools together with preference elicitation protocols in order to generate descriptive innovation by being able to describe the value trade-offs among conflicting objectives for the different participants involved in the process. We also integrated visualization tools with real-time sensitivity analysis in order to generate predictive innovation and making our stakeholders and the client aware about the impacts that changes in the models can have on the final results. And you can see that these analytics are embedded within a prescriptive type of intervention. In this case, by prescriptive type of intervention, we mean a decision-making process where we developed a structured way of analyzing the problem, including facilitating participation, but also being aware of descriptive realities, meaning insights coming from behavioral decision science. What are the mistakes that we usually make when we are confronted with complex decision-making processes? So, for instance, you can see that we use a value-focused thinking approach rather than an alternative-focused thinking approach, because there is evidence in the literature that if we start from the identification of the objectives and we then generate alternatives based on these objectives and values, we are going to get a better and a more comprehensive solution space. And then there is a fourth analytical component that is represented by the green box, and which I'm going to let you discover throughout the presentation. So, what is important to highlight within this process framework is that we use a facilitated modeling approach, meaning that we work together with the client throughout the whole project, from structuring and defining the nature of the problem situation under analysis to supporting the evaluation of priorities and the comparison of alternatives. And here you can see just that we wanted to give you an idea about the analysis of the literature that we did before testing the proposed analytical approach in this real context. We wanted to see what has been done in the field of transportation planning and abandoned railways line regeneration using decision analytics. What we found is that decision analytics haven't been used to support the comparison of alternative regeneration projects yet. In this context, the problem of abandoned railways has indeed been studied, but more from the point of view of the ecological impacts that an abandoned railway can have on the surrounding environmental system, or they were focusing on a single project. And analytics and operational research tools have been used in this context, but more for scheduling or optimization problems, whereas there is a growing need for the use of decision analytics able to support the comparison and evaluation of competing options for the regeneration of these abandoned infrastructures. Here you can see that we are working in the Piedmont region in the northwest of Italy, and where 13 railway lines have been abandoned since 2012. This is quite a big number. So together with the clients, we started by focusing on the first one, that is the most strategic abandoned railway line in this geographical context. This is the Pinerolo-Torre Pellice railway line, which stretches for 18 kilometers in a context that is a mixed urban and rural geographical area with a high touristic potential. Here you can see the model that we developed. So the ultimate goal is to identify the best scenario for the requalification of this specific abandoned railway line that we started focusing on. This was to test the applicability and the operability of the proposed analytical approach in order to leave our client with a working tool that they would have been able to then use again in other similar as well as different decision-making processes. As you can see, we also identified several attributes that have been grouped into two main categories: environmental factors and socioeconomic factors. And you can see that we have a balanced value tree, and the reason for this is that we wanted to avoid the splitting bias, which means that we would be naturally tempted to give a higher weight to those objectives that are specified by a bigger number of sub-objectives. So it's really important in a decision-making process with real clients to have a balanced structure of the decision-making problem. And what are our alternatives? We generated and considered 5 alternatives for this problem based on stakeholder analysis, an analysis of the best practices available worldwide, and on a value-focused thinking approach. And here you can see them. So the first one is to regenerate this abandoned railway line as a greenway, meaning that these 17 kilometers of railway are going to be recovered as a path for pedestrians, bicycles, horseback riding, and this is also going to promote the touristic development in the geographical area under analysis. The second alternative is the rail banking, which consists in ordinary maintenance work to ensure standards of quality and safety and efficiency that are compatible with a possible reopening of the railway in the future. The third alternative consists in the extension of the urban railway service, meaning special buses that are able to go to drive on the railway tracks. And the fourth alternative consists in the recovery of one of the station buildings that fall into disuse across the different municipalities that are crossed by the railway line, and it's going to be recovered for touristic purposes, so as a bed and breakfast. And the last option is the no action option, and meaning that we leave the natural evolution of the territorial system under analysis without any need for intervention. When we are dealing with projects affecting the environmental system, from the point of view of environmental impact assessment procedures and strategic environmental assessment procedures, it is really important to take into account the no action option to be able to show at the end of the process if there was actually a need for a project or not. And we are going to find some interesting results, which I'm going to share with you in the conclusion of this presentation. So here you can see that once we identified the objectives for our client in this decision-making context and the alternatives under analysis, we collected together with them the performances for the different alternatives across all the considered attributes. Some of them are qualitative, based on expert judgment. Some other are quantitative, as for instance, the square meters of new green areas. And before I show you how we actually developed the model, I would just like to highlight the motivation for our selection of this combined analytical approach within this context of analysis. As we know, in theory and practice are the same, but in practice they are not. And this is particularly true in the context of decision analytics applied for real-world decision-making problems with real clients and real stakeholders. Because there are elicitation protocols that are very well known in the literature, very well consolidated, but when we try to use them with the clients, then there might be problems because the cognitive burden associated to this kind of elicitation protocol is significant, and this can translate into the client or the stakeholders being unable to actually provide an answer to the different elicitation questions. So that's why we decided to use descriptive analytics in this intervention by integrating a very well-known preference elicitation protocol, that is the bisection elicitation protocol, together with interactive visualization tools. And there are some essential ingredients to integrate analytics with visualization tools that are, these tools have to enable both experts and non-experts to collaborate in quickly deriving insights and predictions. These visualization tools need to be able to present the data in a user-friendly way, and also the interfaces that we use need to be clearly understood by both experts and non-experts participating in the process. And this is exactly what we try to do within this intervention. So, to give you an example of what we did, here you can see an example of a value function elicitation kind of question. We are using the bisection elicitation protocol, and the procedure consists in identifying the 25, 50, and 75% on the y-axis, asking the client or the stakeholders for indifference points. So, when we started this process, the kind of question that we have to ask to the client is to imagine two different scenarios. In the first one, we ask the client to consider an increase in the square meters of new green areas, that is one of the attributes under consideration for the decision-making problem, from 0 to 80,000. In the second scenario, the increase is from 80,000 to 160,000. And then the question is, are you equally satisfied with these two situations, or do you prefer one over the other? And what happened in our intervention was that the client was actually unable to provide an answer because the elicitation protocol was generating very abstract questions. So we took some time and we developed this interactive visualization tool in which we were basically associating a picture of very well-known green areas that are very well-known for people working or living in this region, and we were associating them to the different quantities that we were asking the client to consider. So the new kind of question when we came back with this interactive visualization tool became imagine two different situations. In the first one, the square meters of new green areas are going to increase from having nothing to something that is as big as Parco Sempione. In the second situation, the increase in the square meters of new green area is going to move from something that is as big as Parco Sempione to something that is as big as Piazza d'Armi. Are you equally satisfied, or do you prefer one over the other between these two intervals? And now the client was able to actually provide us with an answer, and he acknowledged that the protocol was much clearer to understand and also made him realize in a more effective way what are the trade-offs among the different levels of the attributes. So we were able to fill in the value functions for all the attributes under consideration for this specific railway line under consideration, and the result of this preference elicitation step is that we obtain an evaluation matrix where basically all the performances are now comparable to each other because they represent the level of achievement of the objectives. The next step consisted in preference elicitation about the weight, so the different level of importance of the attributes under consideration. And here you can see an example of the questionnaire that we were using in order to apply the swing weights elicitation protocol. Mention has to be made to the fact that we were working in a focus group setting with 7 participants, both experts and stakeholders. So we had experts in the field of transportation planning, landscape ecology, decision support system, but also consultant for the Piedmont Region Authority in the field of transportation projects and projects about the river basin management in the geographical area under analysis. So how does the swing weights protocol work in this context? You have to ask the client to think about an hypothetical situation in which all the attributes are at their worst possible level, and then provide an opportunity to improve just one of the attributes by swinging it from the worst possible level to the best possible level. And the reason why we were using this elicitation protocol is linked again to awareness of behavioral insights about decision-making processes, and in particular was to avoid the range insensitivity bias, meaning that a common mistake that we can make in complex decision-making processes is to give weights without considering actually the range of the different attributes, and there is evidence that this has dramatic impacts on the kind of results that we can obtain at the end of the process. So here you can see some intermediate results from the point of view of the weights that we obtain from the different attributes under consideration. As I mentioned before, we were working with a focus group of both experts and stakeholders. So you can see that there is variability in the weights provided for the different attributes, but this was largely expected given that all the participants had different backgrounds and very different expertise. However, there is agreement on the most important attributes from both points of view. So from the environmental factors point of view, you can see that 4 experts out of 7 actually agree in considering the new green areas as the most important feature. And from the socioeconomic factors point of view, you can see that 4 experts out of 7 again consider the number of potential users as the most important features from this point of view. So here are some partial results. You can see the final ranking of alternatives from the point of view of the environmental factors and from the point of view of the socioeconomic factors. So from the environmental factors point of view, the green way is the winning alternative, although it has a very bad performance from the point of view of the duration of the construction work. That is the red component. And this is the fact of using a compensatory aggregation rule, like the one that we use in this case, according to which a poor performance on one attribute can be compensated by a good performance on another one, thus leading to an overall good result at the end. From the socioeconomic factors point of view, you can see that the winning alternative is the urban transportation extension, followed by the old station recovery and the greenway. So what we did at this point was that we used predictive analytics to show the client what could happen if we change the weight of some attributes in the model, what could be the impact of these changes on the final results. And we were using no sophisticated software, we were using an Excel file which we pre-programmed in order to have sliding bars, and by moving these sliding bars within a focus group setting, we were able to show in real time to the different participants what was happening to the final ranking of alternatives by plotting the map with the final ranking of alternatives for each change that we were performing in the weights. And this supported a more informed discussion among the participants, a learning effect, and above all, a discovery of what are the most critical criteria in the decision-making context under analysis, meaning those criteria that have the power to change the final ranking of solution based on small changes in their initial weights. how did we use the prescriptive analytical component in order to provide a final recommendation? Here you can see our final result from the point of view of both environmental factors and socioeconomic factors. You can see that the green way is the best performing alternative, but very closely followed by the extension of the urban transportation system, and surprisingly, the no action option is not the worst alternative among the considered set. Actually, the rail banking option is the worst option, meaning that this is probably not a suitable project within the geographical context under analysis. However, it might be interesting for some of the other railway lines abandoned within the region. To conclude the presentation with some highlights on the feedback that we received from the participants, on the innovative value of the project and on its impact, let's start from the feedback that we received. All the participants appreciated the role of the facilitated modeling approach, and especially the fact that through this mode of engagement, we really made sure that they all had the same understanding of the attributes under consideration, the objectives, and the decision-making problem under analysis. They acknowledged the transparency of the process, and in particular, one of the participants stated that he found it more difficult to influence the results with an hidden agenda compared to other unstructured negotiation processes that he participated in. They acknowledge the clarity and intuitive interaction with the data visualization analytics, and there were also comments about the improved level of knowledge of the scientific team that was a result of the real-time sensitivity analysis developed within the focus group setting, where they all became aware of the arguments in favor and against the different alternatives. And finally, they stated a willingness to reuse the developed methodological framework, not only for the remaining abandoned railway lines within the geographical region, but also for other projects when a decision has to be made among competing alternatives. So let's now see what we are doing to move forward with this project. The analysis of the recommendations in a decision-making process may stimulate further questions from the point of view of the client or the stakeholders participating in the process, and this was indeed the case in our process. So you may find some of the stakeholders that are interested actually in knowing what are the improvements that are required on some of the attributes in order for the alternative that they support to achieve a better position in the ranking. Or, on the other side, what are other stakeholders might be interested in knowing what are the maximum deterioration that the alternative they are supporting can achieve in order to maintain its current position in the ranking. So what we are doing now is that we are studying the role that performance-based post-factum analysis can have in order to answer this question. And this would be, again, a kind of predictive analytical component of the intervention. So finally, what is the innovative value of the contribution? The context of our application, so policy analytics and rural and urban regeneration processes, the fact that we, by integrating decision analysis with a facilitated modeling approach, we generated prescriptive innovation. Prescriptive in this case meaning that we were aware of behavioral insights evidence, and we were just trying to minimize or avoid biases such as the splitting bias, a non-comprehensive generation of objectives, or the range insensitivity bias. Then, by developing and testing a visual preference elicitation protocol, we developed a descriptive innovation because we became able to show in a graphical way the value trade-offs that the participants were making among conflicting objectives, and by developing real-time sensitivity analysis, we generated predictive innovation. Then, this represents the first application of multi-attribute value theory in the context of disused railways requalification, and rather than using a sequential design for the different analytical components that we use in the process, we really embedded the descriptive and predictive analytical components within a prescriptive intervention. So from the creativity point of view, we can summarize the intervention by saying that we integrated visual analytics with well-known preference elicitation protocols, thus improving the protocol and making it more user-friendly. The fourth type of analytics that we believe we use in this intervention is the constructive analytics approach. We took inspiration from the constructive decision-aiding approach that has been suggested in a paper authored by Tsukias, meaning that we really constructed both the problem and its solution together with the client, working with them since the very beginning of the process. We didn't use any sophisticated software, but we adapted in a tailor-made, according to a tailor-made approach, an Excel file in order to be able to use that in a participatory setting, and we avoided the black box effect by trying to develop as much as possible a transparent decision-making process. So the impact of this work has to do with the implementation of an approach that can have a widespread use. As we were discussing at the beginning of this presentation, many countries are facing similar projects, and the regeneration of abandoned buildings and disused infrastructures is at the forefront of the worldwide agenda. We also, another impact has to do with the learning effect that was acknowledged by the participants in the process, and there is a business value because we developed a software that is an open source software which is implementing these integrated visual analytics approach and preference elicitation protocols to deal with complex decision-making problems. So, in conclusion, the main contribution of this work can be summarized as follows. The first one is that we improved a well-known elicitation protocol, that is the bisection elicitation protocol for preference elicitation, by integrating it with visual analytics, and this is expected to increase the use of decision analytics in practice. And secondly, the replicability of the proposed methodological analytical framework, both in the short term, because it can be applied for dealing with similar projects, as for instance the remaining abandoned railway lines within the regions, or in the long term as it can be used for dealing with similar as well as different decision-making problems where a decision has to be made among competing alternatives. So, thank you for your attention.